In this video, I'll demonstrate how to use the MyCurveFit Excel Add-in to perform a Michaelis-Menten curve fit from directly within Excel without the use of Solver. Using Solver to perform a Michaelis-Menten fit can be difficult as it requires estimating the Km and Vmax values, calculating the theoretical velocity and squared sum of differences, and then optimizing the fit. With the MyCurveFit Excel Add-in, to perform a Michaelis-Menten fit, all that's required is your X and Y calibrator values. I have open an Excel spreadsheet with my substrate values and my observed velocity values. The substrate will constitute the X values, and the velocity will constitute the Y values. To calculate the Vmax and Km, I'll first select at least two cells to house those parameters, an additional column to include the parameter titles, and a third row to include the R-squared value. I'll type equals MyCurveFit and select the Michaelis-Menten option. I'll select my X and Y values and press Ctrl-Shift-Enter to calculate the parameters. And here we can see the Vmax, Km, and R-squared values have been quickly and easily calculated for us. If we'd like to see additional goodness measures, including the squared sum of error, we can highlight more cells when calculating the curve fit parameters. I'll highlight this block of cells and again enter equals MyCurveFit, select the Michaelis-Menten option, highlight my calibrator X and Y values, and press Ctrl-Shift-Enter to calculate those parameters. You can see here the additional goodness measures that have been added, including the SSE, which is quite small for this data set. We can also plot the curve by creating a plot data table and a corresponding scatter chart. I'll create the plot data table directly below the calculated parameters. The X values should span the range of the calibrator X values or the substrate values. My table includes values from 2 to 60. Next, I'll calculate the Y values corresponding to these X values by entering equals MyCurveFit and selecting the Michaelis-Menten Calc Y option. I'll select the Vmax and Km values and press F4 to add $signs to denote this selection as an absolute reference. Next, I'll select the X value and press Enter. Because I designated the calculated parameters as an absolute reference, I can drag this formula down the remainder of the plot data table. Next, I'll highlight the calibrator X and Y values and select to insert a scatter plot. I'll move this chart up to the top of my sheet to simplify viewing my result information. Next, I'll select to format the data series to add a solid, smoothed line and remove the markers. Now on our chart, we can see the curve fit line. This data represents the true curve fit line as opposed to a line simply connecting our calibrator points. Now I'll add my calibrator values as an additional data set by selecting Select Data, selecting Add. I'll name this series Calibrators, and I'll select my calibrator X and Y values. I'll format this data series to remove the line and add markers. Now on our chart, we can see both the curve fit line as well as where the calibrators fall on that line. For more information on how to create plot data tables and the corresponding curve chart, please see the associated video. With this in place, our calibrator data has been used to calculate the Vmax and Km values for a Michaelis-Menten fit, and the resulting curve has been plotted. Another excellent benefit of using the MyCurveFit Excel Add-in is the ease of analyzing additional data sets. All I need to do to analyze my next data set is to simply copy and paste in the calibrator data. I have another data set on sheet 2 of this spreadsheet. Highlighting those values, I'll copy and paste these in to our existing calibrator table. You can see my curve fit parameters are automatically updated, as well as the chart. If you have any questions about using the MyCurveFit Excel Add-in to calculate the Vmax and Km values using a Michaelis-Menten curve fit, please email us at support@myassays.com.